Alright, this is 7.3, linear functions. A linear function is a function whose graph is a straight, non-vertical line. These are written in the form y equals mx plus b, where m is the slope and b is the y-intercept. If you need help with that, you need to refer back in your notes to when we were working with slope-intercept form. So, we are going to use the graph to write a linear function that relates y to x. This means we're going to write an equation in slope-intercept form. So here is my graph, and I can look and see what my y-intercept is. That's easy to identify right away because that's the point where it crosses the y-axis. But I also need to find the slope of the line, so I can do that in two ways. First way, I can use algebra and my formula for slope and solve, or I could count. So I'm going to use my formula, and then I'm going to check it by counting. So I'm using the first 2 points here, and my slope is 1/2. And if I count, I'm going to go up 1 to the right 2. So I know that it's rise over run, so 1/2 is my slope. Then I'm going to plug that into my slope-intercept form, and I have y equals slope of 1/2 x plus 1, because my y-intercept is positive 1. And it just said to write an equation, so that's all we do. Now we are going to use a table to write the linear function. So I have this table here, and the first thing I notice is I have x is 0, and I have a y value. So I'm going to find the slope, then use my y-intercept and plug it into the formula. So using any 2 points you want to, I used point 1 and point 2 here as labeled, and my slope is 2. When x is 0, y is 3, so this is going to be my y-intercept or my b value. So then plugging this in to slope-intercept form, you get y equals 2x plus 3. If you do not have the y-intercept given, you will need to use point-slope form, then solve for y. So let's look at this one. I am given a table. I do not notice that there are any x values that are 0, so I will have to use point-slope form and then solve for y. Point-slope form is y minus y1 equals m times x minus x1. So using points 1 and 2 to find the slope, my slope is 3. And plugging this into my formula, it does not matter which point you use as long as y and x come from the same point. So if I use the first one, I have y minus 12 equals 3 times x minus 4, 3 coming from my slope. Then I need to distribute and solve for y. And then I will get y equals 3x plus 0. So, employee A earns $20 per hour and has a $30 bonus. That is a one-time, you're given $30 on top of whatever you make in your hours. The graph shows the earnings of employee B. Which employee has the greater hourly wage? So we know employee A is 20 per hour and then 30 on top of that. Employee B, we can see for 1 hour they earn 25, for 2 hours they earn $50, and 3 for 75, and so on. So to solve this, to answer the question, I'm going to write equations for each employee, then compare. So employee A, I'm going to have y, which is going to be how much they earn. 20 is the rate, that's what they gave me in the problem. X is the number of hours, and 30 is this bonus. So the 30 does not change for how many hours, it's just a one-time flat bonus. Then for B, I have how much they earn equals how much they earn per hour times the number of hours. So I can see for 1 hour it's 25, 2 is 50. So my slope would be 25. And it starts at 0, so I don't have a y-intercept of adding anything here. So then I look and see which employee earns more per hour, not total, but per hour. And that is employee B. So if we look at their slope of the equations, that will tell the rate, or their hourly wage. But if we say after how many hours does employee B earn more money, so I can make a chart, and I have employee A, employee B, and this is for each hour that they work. And if I continue to write this out more and more, I can see at hour 6, they earn the same amount of money. Then in hour 7, employee B starts earning more. So it's after hour 6. During the 7th hour, B earns more money. So the answer is after 6 hours, employee B earns more money.